Okay, now we're talking about exponential decay, and this is important for when we have things that are depreciate or radioactive decay. Think of like cars that depreciate in value, or anything else that you lose money on. That's what exponential decay is useful for modeling. So we're still going to use our formula from exponential growth. The only difference is that our b value has to be between 0 and 1. Okay, so we're talking about fractions, decimals, things like that. Now, it can't just be any fraction or any decimal. So like if I had 1.5, that obviously that's not in between 0 and 1. So it has to be something like 0.5 or a half or 7/8 or something like that. If I had even a fraction that was bigger, like 8/7, that is not in between 0 and 1. Okay, so you can see how our b value here, that's between 0 and 1, and our b value here is between 0 and 1. That's how we know that it's exponential decay. The nice thing about the base, if you think about the base being a percentage, if it's in a decimal form, the base tells you the percentage of the original value that is left over. So if I see 0.9, I know that next year that it's going to be worth 90% of what it originally started at. So if I have maybe, I don't know, an old iPod that started off at $200, the following year it's going to be worth 90% of that value. Or for example, if I bought a car, like an expensive car for $15,500, I would know the next year it's only going to be worth 85% of the original value. Okay, so A, remember, is your starting point. That's our y-intercept. All right, and then that b value is our percentage that's left over. So now let's go through these and see which one would be growth or decay. So we're always looking at the b, the number that has the exponent on it. That's bigger than 1, so that means it's growth. This one over here, 0.99, that's smaller than 1, so that means it's decay. Okay, over here, 0.1, that is smaller than 1, so that's decay. And then over here, 1.1, that is bigger than 1, so that is growth. Okay, do you notice how I didn't even bother looking at the a value? That's not what we look to determine whether it's growth or decay. So in both of these examples, we can tell that these are decay, and I'm going to start off doing the same thing. My a value is 1, my b value is 0.25. Okay, so if I graph this, I'm going to use the same techniques as the growth. My y-intercept is still going to be my a value. My domain is still going to be all real numbers. My range is still going to be greater than 0, or if we had a k value, it's going to be greater than k. And then my asymptote is going to be whatever my k value is. Okay, the only difference is it's going to be decreasing instead of increasing. It's going to be falling instead of rising. So for example, if I do my little table and I do my normal negatives and positives, if I plug in -2, that's going to be positive 16. If I plug in -1, that's going to be positive 4. And then if I plug in 0, that's 1. If I plug in 1, that's 0.25. And if I plug in 2, that's going to be, let's see, 1/16. I'll have to do that as a decimal later. All right, so -2/16, that's off my chart. All right, that's off my graph. -1, 4, 1, 2, 3, 4. And then 0, 1, and then 1.25, and then really little bitty. So here's what it's looking like. So you see it still has that sharp curve, it's just it happens first, and then it gradually decreases. Okay, I still have that asymptote, it still flattens out at 0. Over here, my a is 1, my b is 0.5, so let's use our shortcut. We know that the y-intercept is going to be the a value. So I know it's going to be here at 10. And then when x equals 1, y is going to be equal to a times b, so 10 times a half, and that's going to be 5. So when X is 1, 1, 2, 3, 4, 5. Okay, and then I know it's going to flatten out right here at 0. So it's going to look like this. Okay, so that's a quick way to do our exponential decay graphs. And again, we have to think about what's going to happen if I add or subtract in the exponent. That's still going to shift left or right in the opposite direction, just like your h value. Okay, and then if I add or subtract afterwards, after the exponent, that's going to shift up or down according to, or depending on, the k value. So this one would shift up